In this video, we're going to be focusing on cranial cavities mathematical problems. Let's assume you're given this kind of problems and you're asked to calculate the volume, morphometric analysis, mean and standard deviation of cranial cavity. How can we solve this problem? First thing you need to understand is this. In order for you to calculate the volume of cranial cavity, you typically need to use the imaging techniques such as MRI or CT scan to obtain the accurate measurement. The cranial cavity actually houses the brain itself, so its volume can vary from person to person. In simple terms, we can say it has, like human beings have different volume of cranial cavity. So let's see how we can solve some simple problems concerning the cranial cavity itself. Starting from the calculating the volumes, then we dive into morphometric analysis. We look at the mean and standard deviation. In this case, when the mean and standard deviation has to do with group or set of people. Let's start with the first one. Let's say you asked to calculate the volume. Let's say you're given, let's say cranial cavity. Let's say this has the length of 15 centimeter. The length from here to here, let's say it's 15 centimeter. And it has the width to be 10 centimeter. Also, it has the height to be 12 centimeter. And first thing we need to calculate is first to calculate the volume. When we ask to calculate the volume is simply going to be length, as the formula, length multiplied by width multiplied by height. We can use the arbitrary alphabet here. We can set L, which stands for length. We're simply going to multiply it by W, which stands for width, and H, which is height. Volume, what is the value of our length? We said our length is 15 centimeter, which is the distance from here to here. Let's indicate it. Length is 15 centimeter, and the height, which is 12 centimeter, then the width, which is 10 centimeter. In this case, we can say, since our length is 15 centimeter, this is simply going to be 15 centimeter. We're going to multiply that by our width, which is what, 10 centimeter. Multiply by our height, which is 12 centimeter. Punch on your calculator. If you said 15 multiplied by 10, this is simply going to be 150. 150 multiplied by 12, this is simply going to be 1,800. Remember, the unit of volume is in centimeter cube. Volume is simply going to be 1,800 centimeter cube. So let's start with the next thing we need to look at is the morphometric analysis. In this case, we can set measurement of skull length and width. Measurement of skull length and width were taken from a sample of 50 individuals. I'm just trying to give an example. First thing we need to do is to calculate the mean and standard deviation of those measurements. Okay. Let's say we have different individuals with this measurement. Let's say the first individual we have, it happens to be 120 millimeter. Next individual, let's say we have 125 millimeter. Next one, let's say we have 118 millimeter. The third one, 121, let's say millimeter, and we have 117 also in millimeter. In order for us to make it easier, since we are trying to check the samples of 50 people, which taking it this way is simply going to be, it's not going to be easy, really. Let's try to say, okay, if that's the case, since we already have 50 here, sorry, 5 multiplied by 10, this is simply going to be 50. Let's say each individual here, we multiply it by 10, meaning that in the set of 50 people, we have 10 people with 120 millimeter measurement of the cranial cavities. So this is going to be multiplied by 10. Let's multiply everything. 118 millimeter multiplied by 10. 121 millimeter also multiplied by 10. 117 also multiply it that by 10. So what is next? So we need to calculate our mean. So our mean here is simply going to be what? Summation of x divided by n. And this is simply going to be, we need to multiply 120, right? Okay, let's put it down before doing the mathematical operations. So we can set 120 multiplied by 10. Remember, it's in millimeter, but we are going to put that later. We are going to plus it with 125, multiply it also by 10, remaining 118. Don't forget to multiply it by 10, then multiply by 121. 121 also multiply by 10. The last one on the list is 117, also multiply by 10. Let me just put it that way. Then we are going to divide it by n, which is the total numbers of the population, which is 50. In this case, we are going to multiply by 50. So our mean here is simply going to be 120 multiplied by 10. This is simply going to be 1,200. 1,200 plus 125 multiplied by 10. It's going to be 1,250 plus 118 multiplied by 10. This is going to be 1,180 plus 1,121 multiplied by 10 is going to be 1,210 plus the last one, which is 170 multiplied by 10, which is going to be 1,170. Still, at this point, we are going to divide everything by the total number of the population, which is simply 50, because our n stands for that. So this is going to be 150. So our mean here, next thing we need to do is to plus everything and divide it by total number. If you plus 1,200 plus everything at the numerator, you're going to end with 6,010 divided by 50. 6,010 divided by 50, we are going to have our mean to be 120.2, which is also still at that range. So next thing we need to do at this point is for us to just find our, standard deviation. What is the formula for us to find our standard deviation? For you to find a standard deviation, the formula is simply going to be, let's say standard deviation SD is going to be the square root of what? Summation of x, you can set xi anyhow, let's just say xi minus x bar to the power of 2 divided by n. At this point, the first x here, xi, is simply stand for each value of population, while the x bar here stands for the population mean, and this n actually stands for the numbers of people in the population. Next thing you need to do here is to insert a value and feel free to get the final answer. So this is it for this problem. On our next video, we are going to be looking at the biochemical modeling of a cranial cavity. So thank you for watching. In this